Hi, and welcome to this week's video lesson on successive transformations. Our learning goal for this week is I can draw and describe the image of a shape after repeated transformations. And our learning goal is I can talk about shapes using words like coordinates, vertex, vertices, translate, reflect, and rotate. Let's begin with successive translations. Which type of transformation does this diagram show? Take a second and think about it. We start with a shape, and then we show image A, image B, and image C. What kind of transformation is this showing? It's a translation, and specifically 2 units right, 1 unit up. How can we check? Well, we're going to take 1 point on this shape. I'm just going to pick the bottom left-hand corner. And we're going to find this same point on the image, and we're going to count how many units it moves. So we go 1, 2, that makes 2 units right. And then we go 1 up there to get to the same spot. So 2 units right, 1 unit up. And that matches with what we have here. So we have the correct translation described there. So we can see from this that the same transformation can be applied to a shape more than once because we have this transformation going from shape to image A, and then from image A, the same transformation going to image B, and then to image C, the same transformation again. So we have the transformation happening once, and then twice, and then 3 times. Next is to describe a transformation that moves the shape directly to image C. So we described a transformation that takes the shape to image A, but what transformation would take the shape all the way to image C without having to go through image A and image B to get there? And there are 2 ways we could do that. We could do the same thing again where we count all of the units that we have to travel to the left or right, and then all the units that we have to travel either up or down to get our answer, which is 6 units right, 3 units up. And if you were counting as I did this, you would have seen that we did go 6 units to the right and 3 units up. But there's another way to do this. And if we remember, we did 1, 2, 3 of the exact same transformation. And we know what that was. It was a translation of 2 units right and 1 unit up. And we can take that information and say 2 times 3, because we're doing this translation 3 times. 2 times 3 equals 6. And if we take this, 1 times 3, because we're doing that translation 3 times, 1 times 3 equals 3. Well, that gives us our translate the shape 6 units right, 3 units up. So we can either count all these units 1, 2, 3, 4, 5, 6, 1, 2, 3, or we can figure it out knowing that we're doing this translation 3 times and knowing what the translation is for us, or what the units are for a single translation. So when a shape is translated 2 or more times, we say that the shape undergoes successive translations. So that word successive means 2 or more times. The same translation may be repeated as shown in this picture, or the translations may be different each time. The same holds true for rotations and reflections. Next, let's talk about successive rotations. This is trapezoid PQRS. Trapezoid PQRS is about to undergo successive rotations. And if we remember from talking about successive translations, that means performing a transformation 2 or more times. So this trapezoid, PQRS, is about to undergo rotations 2 or more times. That's what successive rotations means. Trapezoid PQRS is rotated 180 degrees about vertex R, which you see here in red, and you can see this arrow indicates the 180 degrees and the direction, which in this case is clockwise because it's moving in the same direction as the hands on a clock. The image is called P prime, Q prime, R, S prime. Since vertex R doesn't change, it stays in the same spot, we still call it R, not R prime. Then the image of trapezoid P prime, Q prime, R, S prime is rotated 90 degrees clockwise about its top right vertex, P prime. The final image is called P prime, Q double prime, R double prime, S double prime. And in this case, since vertex P prime doesn't change, we don't refer to it as P double prime, we keep it as P prime. Now, the trapezoid and both its images are congruent. That means that all the corresponding sides and corresponding angles are equal. And we can prove this by tracing the trapezoid each time. If you have tracing paper, you can do this, or even some thinner paper, or if you color your trapezoids in and use a darker color, you can usually see through enough to be able to trace and then cut out the shape and turn and place it on top of the images, and you'll see that they are all congruent. If your images are not congruent with your original shape, then you know that you did something wrong in your transformation. Hexagon A double prime, B double prime, C double prime, E double prime, F double prime is the image of hexagon A, B, C, D, E, F after 2 successive reflections. So this is a little complicated, but let's review how we can figure this out. Sometimes with successive reflections, it does take a little bit of guess and check, but I'm going to walk you through the steps right now. So what we want to do to identify the reflections is to make a reflection of our original shape so that line segment AF in the reflection is in the same grid line as A double prime, F double prime. Now we could have done that with line segment BC if we wanted to, but to make things a little easier, we're just going to go with AF because it's on the far left-hand side. Now, to reflect this shape so that the reflection of line AF is in the same grid line as A double prime, F double prime, we need our line of reflection to pass right through here so that our shape is just reflected straight over like this, and A prime, F prime is now in this same grid line as A double prime, F double prime. Okay, so that is our first step. I'm going to change the color so that we can see more easily what our second step is. So that line of reflection needs to pass through the same line as BC. So now we can name our reflection image A prime, B, C, D prime, E prime, F prime. And we don't change BC to be B prime, C prime because they don't change position. All right, bear with me. It's going to make more sense when we move to the second step. Here we go. So the next step is to reflect A prime, B, C, D prime, E, F in a line of reflection that is horizontal and 1 unit away from line segment E prime, F prime. And you can see how we arrive at this reflection image, A double prime, B double prime, C double prime, D double prime, E double prime, and F double prime. And as with our rotation images, the original hexagon and both of its images are congruent. And again, we could prove that by tracing the shape, cutting it out, and placing it on top. These successive reflections can be really tricky, so we are going to be practicing them during our synchronous sessions, and this may be a good week to join me in one of my extra help sessions so we can do some more practice and you can ask any questions that you may have.